Hello everyone, welcome to Excel's Rapid Focus series. I am Shanthi, Excel's Mathematics faculty. Today we are going to discuss continuity and differentiability chapter. You all know it's very important chapter. So, and the weightage of this chapter also you know, right? Like 35 marks will be there for full calculus part. Full syllabus out of 80, you have 35 marks. 35 marks from the calculus alone. Calculus means differential and integral chapters. I mean calculus. So differential calculus, of course, mostly they will divide the marks into equal. Okay, more like approximately equal marks will be distributed to both calculus, like differential calculus and integral calculus. So here we are discussing continuity and differentiability chapter. As you all know, this chapter has some prerequisites, right? This chapter has some prerequisites. Like last year, the basics of this chapter we studied, right? Like limits and derivatives. We had a chapter limits and derivatives, right? So in that chapter, what all concepts we studied, that all things you need to know here also. Okay, then only you will get something about this. Okay, so I'm directly moving on to the topic now. So listen dears, the first important point here is a function f is said to be continuous at x equal to a if limit x is tending to a f of x equal to f of a. Right? Limit x is tending to a f of x equal to f of a. And you studied limits last year, right? What you studied about limits? Limit of a function at a point will exist if its LHL, left hand limit, equal to right hand limit. The same definition is given here. Limit LHL at x equal to a equal to RHL at x equal to a. Or limit x is tending to a minus f of x equal to limit x is tending to a plus f of x equal to f of a. As an example, we will have a function, suppose limit, see, LHL means limit x is tending to a minus f of x. Limit x is tending to a minus f of x equal to, what is the meaning of the statement? X is tending to a but in the left side manner, right? X is tending to a in the left side manner. For example, suppose if I write here, limit x is tending to 2 minus means the number is tending to 2 but in the left side manner, like 1.99, 1.999, etc. It's very close to 2. Literally saying we are taking a small neighborhood of 2. What is neighborhood? What is neighborhood of a number? Neighborhood of a number is open interval a minus h, comma a plus h, where h is very, very small, negligibly 0. Right? Because the number is tending to 0 but not equal to 0. It's very close to 0. So when limit x is tending to a minus f of x, see, geometrically if I show that, see, when do we say that limit of a function exists? Because after limit only I can explain about what derivatives, right? Continuity, right? Then after continuity only we can explain about derivatives. So it goes as a chain, right? So here, suppose if this is the point, okay, this is the point x equal to a, some point I'm taking, okay, and a small neighborhood of a I'm taking, see, this is a minus h and this is a plus h, that is a minus h. So this point is a minus h, this one, both this, okay, this is a minus h and this is a plus h. Okay, we have taken a very small neighborhood of a. Okay, and in that, if the function, see, function is coming like this, See, at x is equal to a minus, I mean when a limit x is tending to a minus, sorry dears, I'll draw the figure once more. Okay, suppose if the function is like this, so if this is a, I have like this. Okay, this is for a minus h, this is for a minus h, and here suppose if this is a plus h. Okay, so it is one value is to the left of a and one value is to the right of a, but you can see the y coordinate of these 2 points. What is that? F of a minus h and f of a plus h. What is that? F of a minus h and f of a plus h is equal, right? Because see, y coordinate, this length is equal to this length. That means we say that LHL equal to RHL, but still you can see a discontinuity over there, right? Why is it discontinuous? Why is it discontinuous? Because at x equal to a, function is not defined, correct? At x equal to a, if the function's value is same as these 2 values. For example, suppose, see, if I have joined that, now I got at x equal to a also, the value of the function is same. That means literally saying LHL equal to RHL equal to at the point. Hope you all got it. What is the definition of the limit of a function? And see, I have here explained about continuity also. I think you got it. See, function is said to be continuous. Limit already I explained, right? LHL equal to RHL. That time we can say, see, wait, see here. Yeah. In this case, limit is existing. In this case, limit is existing, but function is not continuous. Why is it not continuous? It is f of a value, f of z, whatever is the value we have taken here. That value, at that point, function's value we don't know, right? It is not defined. So that we can't say that. That means when we draw the graph of a function, with a break, see, there is a break here, so we can say that function is not continuous. So I'm going to join this so that now it is continuous. Now it is continuous. Clear? So a function is said to be continuous at x equal to a, geometrically saying if you can draw the graph of the function without lifting your pen from the plane of the paper, we say that the function is continuous. And mathematical language is what? Limit x is tending to a minus f of x equal to limit x is tending to a plus f of x equal to f of a. So hope you all got this. And along with that, I'm just giving you all the results, standard results that you studied last year in limits, because that all things are required here. Okay, so what is that? What are the standard results that you are studying? We will see all the standard results. What are the standard results? It is limit x is tending to 0. What is that? Trigonometric limits. First I will write sin x by x equal to 1, right? Limit x is tending to 0, sin x by x is equal to 1. Next is trigonometry itself. Limit x is tending to 0, tan x by x equal to 1. Like when the angle is very small, when the x value is very small, sin value is approximated to x, or sin x by x is equal to 1. And similarly, what is that? Limit x is algebraic limits. What are the algebraic limits? Limit x is tending to a, x raised to n minus a raised to n by x minus a is n into a raised to n minus 1. So here all we have to concentrate. What is to be concentrated here? Where x is tending to. Where x is tending to. Okay, x is tending to the point A. So that same A should come here. I mean in the numerator. In the numerator, x raised to n minus, after minus you have to have a, and the denominator also x minus a. Okay, and limit x is tending to, next is limit x is tending to 0 e power x minus 1 by x equal to 1, right? Limit x is tending to 0, e raised to x minus 1 by x equal to 1. Then what else is there? You can generalize that result, right? What is the generalization of that result? Limit x is tending to 0, a power x minus 1 by x is also equal to 1. That's generalized version of the same. If e is equal to a, e means, you know, right, you have studied about exponential function and power function, everything. So if e is equal to a, this is the generalized version. Here I can put a value as anything, any real number, right? Similarly, limit x is tending to 0, logarithm function. You studied only one, but for JE and all we have some more results. We studied logarithm of 1 plus x by x is equal to 1. So most of the limit type questions or continuity type questions also we require all these results. So make sure that you know all these things in the proper way. All formulas last year you studied, or you have to remember that. Clear? So this is about continuity. Okay, now we are going to discuss about differentiability. And before we start differentiability, you can just remember about which all standard functions are there. Which all standard functions are there which are continuous everywhere. Everywhere continuous functions. What are they? That you can make as a knot. Okay, if you make as a knot, you will always remember that. Okay, so make as a knot. What is that? What are the different functions which are continuous everywhere? Which are continuous everywhere. Actually, for many functions are there, but the one you have studied. Okay, I am writing here. What is that? F of x equal to all polynomials. General form of polynomial, you know, right? A naught x raised to n plus a1 x raised to n plus etc. Any polynomial that is continuous everywhere. For every real number, it will be continuous. And now f of x equal to, what is that? Sin x. Sin x is our famous trigonometric basic function that is continuous everywhere. Not only sin x, cos x. But from there, tan x onwards, we have some restrictions, right? Because tan x is what? Sin by cos, right? So, where cos is 0, where the denominator is 0, that point it won't be defined, correct, no? So, sin by cos is tan. So, when cos is 0, dears, when it is odd multiple of pi by 2, that value tan is not continuous, right? So that all you can make as a knot of all these things. Sin x, cos x, continuous everywhere. And sin x, cos x is the modulus of x is also continuous everywhere. You all remember, right? Last year, relations and functions we studied. Modulus function, these all are prerequisites for this chapter. What is that? Modulus function, definition. And majority, like in calculus, it's very, very, very important function. Many questions we are applying the definitions of modulus function. Clear? So, modulus is very important. Even greatest integer function is very important. Clear? All these functions you should study properly. So, remember, you have to study all these things before you start. Because if you want to get full marks, you should definitely do hard work. Okay, so maximum hard work you have to do for studying all these things. If the base is not there, you have to take this first year textbook and do study and take as a note, so that you have to you will get the all knowledge about all these functions. Clear? Now, we are moving on to the next topic. What is that? Differentiability at a point. Okay, differentiability at a point. What is that? Differentiability. See, a function f is said to be differentiable at x equal to a if LHD at x equal to a equal to RHD at x equal to a. That is, I think you all know about it, right? LHD, left hand derivative, is equal to right hand derivative. Clear? Left hand derivative is equal to right hand derivative. So the definition last year you studied, hope you remember, derivative using first principle in class 11. What was the definition? F dash of x is equal to limit h tends to 0. You remember, right? You remember, right? Already we know, right? What is derivative? Derivative means rate of change of a function with respect to a variable. Rate of change. So here, change. What is happening to the function? If this is the new one, f of x plus h minus f of x. So it is the change. Rate of change. How much I have increased to x? I increased, whether I increased h is equal to like 0.1, because sometimes we will take 2.01. That means if at x equal to 2, if we are checking 2.01 means what? H is equal to 0.01. Right, so it will be different, right? So h is very small, that is the concept. H is the very small number with negligibly 0. So anyways, how much is that increment? Accordingly, your derivative will also be changed. So f dash of x is equal to rate of change of function, right? Rate of change of function. So listen dears, I need the derivative, right? So differentiability, right? So of course, when I start talking about derivative, this is the definition in my mind. Last year you studied. So you know, right? This is about what? Limit. What we told just now, limit of a function is existing when its right hand limit equal to left hand limit. Am I right? Right hand limit equal to left hand limit. So right hand limit means what? 0 plus. Correct, no? 0 plus. Limit h is tending to 0 plus f of x plus h minus f of x divided by h. And left hand derivative is what? Limit h is tending to 0 minus f of 0 plus f of x plus h minus f of. So same thing we have written like this, but because in your reader it is written like this, both concepts are same thing only. LHD equal to RHD, left hand derivative, because this is derivative definition. This is what? Derivative definition. So LHD. So this is the definition we use for proving differentiability. For proving differentiability, we use this definition. What is that? Limit h is tending to 0, f of a minus h minus f of a divided by negative h. Okay, f of a minus h minus f of a divided by negative h equal to limit h is tending to 0, f of a plus h minus f of a divided by h. It's actually like this. Limit x is tending to a plus or a minus f of x minus f of a divided by x minus a. But dears, at a minus means what? X will be a minus means x will be a minus h. My God, what is this? X is tending to a minus means x is equal to what? A minus h. Right? X is tending to a minus means x is equal to a minus h, where h is very small, negligibly 0. So what you will be getting here? Limit when x is tending to a minus, of course h will be tending to 0, right? F of a minus h, this will be a minus h minus f of a divided by your x is what, dears? Your x is what? A minus h minus a. That is how we have a negative sign here, right? Limit h is tending to 0, f of a minus h minus f of a divided by negative h is equal to, similarly, right side derivative. So it's very simple, all are related also. Clear? Now next is what? Yeah, before we start the next topic, see here, listen. What all types, like how can I compare differentiability with continuity? See, if a function is continuous, can I say that it is differentiable? Of course not, because differentiability means what? Left hand derivative equal to right hand derivative comes, right? So if the derivative of the function at x is tending to a minus should be equal to derivative of the function at x is equal to tending to a plus, right? It should be. Then, but here it is. So, every continuous function need not be differentiable, but the converse is true, right? Every differentiable function is what? Every differentiable function is what? Continuous. So that kind of questions you can expect, you know, right? Assertion, reason questions, they will ask you conceptual based. So if you don't know enough concept, like concept part if not clear, you will be not able to write the answer in the proper way. Okay, so every continuous function need not be always differentiable, but the converse is true. What is that? Every differentiable function is always continuous. Okay, every differentiable function is always continuous. And what is the geometrical meaning of continuity? We already have told, right? Geometrical meaning of continuity we have already explained. So what is the geometrical meaning of differentiability? What is the geometrical meaning of differentiability? Differentiability geometric meaning is, see, there should exist, okay, at x equal to a. At x is equal to a point, there should exist a unique tangent. There should exist a unique tangent. Okay, there should exist a unique, that function, there should be a unique tangent at that point. There should be a unique tangent at that point. So, do you know why it is not continuous, I mean differentiable in the case of modulus function? Why modulus function? Modulus function, as already I have explained, what is that? Modulus function is everywhere continuous, right? Modulus function is everywhere continuous, but it is not differentiable at what point? X equal to 0. Because see, this is modulus function, right? V-shaped graph. So listen dears, we have a unique tangent at this point. At this point, we have only a unique tangent? No, there are two tangents, right, at this point. So that it is not differentiable at x equal to 0. That is our geometrical meaning only, but mathematically you have to explain that. Okay. Okay. Now, next is, after differentiability, we will be moving on to this. These all things last year we explained, we studied. So I'm just moving on to that topic. Y is equal to product of two functions. You remember, right? Product means whenever you have product of two functions, how to differentiate. Everybody knows, right? That formulas of all functions, I will just give that, but it's already known to you, right? You already know all the formulas of derivatives. Just use that formula. See, what is that? You have studied, you might have studied like this. U into V, the whole dash is equal to U dash V plus U V dash. The same thing here. Okay, dy by dx equal to U into dv by dx plus V into du by dx. Same thing, U dash V plus U V dash. Clear? And next is quotient rule of differentiation. What is that quotient rule of differentiation? Here it is. Quotient rule, you all know that, so I'm not explaining more about that. All things last year we studied. Okay, and next is, this is the very important rule. Still if you don't know, like those who don't know about chain rule, of course you will not get very good marks, I'm sure. So everyone, those who are not aware of this topic properly, you have to study that, and it's very easy topic also. Okay, so what is that? See, chain rule, if we have given that kind of definition, I don't think sometimes students will not get it. So I'll just explain that. Y is equal to sine of x. You know the derivative, right? You know the derivative, right? Sine x derivative is what? Cos x. But if I do change this one as sine of x square, what will happen? Sine of x square. So now it is chain of two functions, right? Sine of x square. One is trigonometric function, one is algebraic function. Sine of x square or sine of x cube or sine of root x. So how you will find the derivative? We will, according to that, dy by dx equal to, we will first differentiate sine, what is that? Cos of x square into derivative of x square 2x. Another beautiful version of that chain rule I will give you. See, if y is equal to, if y is equal to f of g of x, okay, all are same only. If y is equal to f of g of x, then what is dy by dx? What is dy by dx? It is equal to f dash of g of x, f dash of g of x into g dash of x, okay, into g dash of x. Dy by dx equal to what? F dash of g of x into g dash of x. So the same thing, sine of x square means, I have to find the derivative of sine. So cos, but I don't write cos x, I will write cos of x square into g dash of x. What is g of x here? X square. So derivative of x square is what? 2x. So I hope it is clear. It's very, very important one. So you have an exclusively one exercise is there for chain rule of differentiation. So do all the questions from your reader, okay, and then you can master all this chain rule type questions, okay. And next is, see, derivative of implicit functions. Let f of x, what is implicit function and what is explicit function? Implicit function means, see here it is written, right, f of xy equal to 0. That means LHS itself will be having both x and y together, which cannot be separated. For example, suppose if you are given sine of x square y equal to cos x, suppose, or simply equal to 0 also, okay. Yeah, sine of x square y equal to 0. Sine of x square. So here it is f of xy equal to 0. Sine of x square y, or x cube y square plus x square into y cube equal to 50. This is also what? F of xy equal to 0, implicit function. So explicit means both variables are separated. Both variables are separated on both sides. So here f of x, so for example, if y equal to sin x plus cos x, y is equal to sin x plus cos x. This is an explicit function, right? Because LHS you have only y, RHS you have x only, right? It is what? It is an explicit function. This is an implicit function. So how do you find the derivatives? We had some that kind of questions. So hope you all remember that. When we do questions, I'll give more examples to that. Okay. Now logarithmic differentiation. Before we start doing what is logarithm function, what is exponential function, what is the graph of that function, all that things I'm not giving because it is right, it's rapid focus series, so I had to complete all the things within a short span of time. So logarithmic differentiation, so what all things you need to know, just make a note of that. What is that? You should know about logarithm function. When we start learning a function, you should know what? Its domain, its range, all its whereabouts. Okay, domain, range, graph of the function. Similarly, logarithmic function and exponential function, they are inverses of each other, right? So these two, and all the rules of logarithms. Okay, logarithm of product, logarithm of division, all that rules. Okay, base changing rule, everything you should know. Okay, not giving all that thing. So this is to be, and mostly we use logarithmic differentiation. Mostly only I didn't say that only for these kind of questions we use logarithm. Logarithm actually can be used for any question, because logarithm is used for what? We are using logarithm for making our calculations in a similar way, right? So if we are getting a very complicated function, we will definitely use logarithms. We don't need to always the equation of this type. Okay, so sometimes y is equal to, it can be like this also. See, suppose the function, very beautiful function, right? Suppose we have a function like this, x plus 1 into x plus 2 into x plus 3 into x plus 4 into x plus 5. If I start differentiating, the question is, find dy by dx. If I start differentiating, of course, from morning till evening, I have to sit for this, right? Because, yeah, first to do product rule, next to do etc. etc. So many things to be done. But instead, if I use logarithms, it would be very, very, very easy, right? How? I can use, I can use what? I can use logarithm on both sides, right? Log of y is equal to, right? Logarithm of y is equal to what? Logarithm of x plus 1, because product of all the terms, right? When we apply product of all the terms, what you will get? Logarithm sum of their logarithms, right? That is logarithm of x plus 1 plus logarithm of x plus 2 plus etc. Sorry dears, I am very lazy to write all that term. So you can write and find the derivative. You know, log y derivative is what? 1 by y into dy by dx. Okay. And logarithm of x plus 1 derivative is 1 by x plus 1. Logarithm of x plus 2 etc. But still, it's easier than our usual traditional method. Am I right? Okay, so that means, so that is what I'm telling. This is normally, this one is used to differentiate the functions of the form u of x raised to v of x. It can be sometimes u of x raised to v of x or u of y raised to v of x. That also can be. Both base and power should have variables. Okay, variables. For example, 3 raised to x, 3 raised to x. I don't need to use, okay, 3 raised to x, I don't need to use that. 3 raised to x is, what is that? Base is not a variable, correct? No, I can use simply a raised to x formula. A raised to x is a raised to x is a raised to x into log a. I can simply use that. I don't need to use logarithm for that, okay? But if I have x raised to x, if I have x raised to x, or if I have y raised to x, if I have y raised to y, all these type questions, we use what? Logarithms. Clear? So, next one is parametric differentiation. You know, right? Parametric differentiation, when to apply? It's written over here. X equal to a function of t, y is equal to another function of t, then dy by dx equal to. How to find derivative of y with respect to x? For example, if I have x is equal to t square, y is equal to t cube, okay, or y is equal to sine t. If x is equal to t square, y is equal to sine t. You can look at here, dears. Both x and y are functions of another variable t. That variable can be sometimes t, sometimes theta, sometimes phi, etc. etc. So, how to find dy by dx? Rule is the dy by dt divided by dx by dt. Hope you all remember this. We have already learned all these things. And you know, right, this is very important, parametric differentiation. Without parametric differentiation, there won't be a question paper. So, it's very important. Okay. Now, next is, so that's about full topics like differentiation. And now second order derivative is also there, but you know, right, what is second order derivative means? You have to differentiate one more time. Dy by dx, if you differentiate one more time, you will get second order derivative. Okay, now you have to know all the standard results of derivatives. You know, right, sin x, x raised to n x raised to n minus 1. Derivative of k, 0, root x, 1 by root x, sin x, cos x, etc. etc. All these results you must know. Before we start doing, everyone should make sure that I know all the basics. If you know all the basics only, we can go to the questions. The problem is students will start directly the questions without knowing the basics, without knowing the fundamentals. They will start directly. So that time you will definitely find a difficulty. Okay, so we will close your book, right? When we are finding difficulty to a particular topic, we will close the book. Okay, so that should not be happen. You have to study all the results, all the basic ideas, everything you should have. Okay. Okay, dears, we are moving on to the problems. Okay, y is equal to logarithm of x square by e square, then d square y by dx square. I mean, you are supposed to find second order derivative. Clear? So of course, without finding first order derivative, you can't find second order derivative, right? And the base here is e. Base of logarithmic function is e. Okay, no problem. You can just discard it because it is natural base only. But if base is other than e, if any other number comes like 2, 3, 4, etc., that time you have to consider. For example, suppose if you get like this, you have to consider, because it is of the form log a to the base b. You remember, right? The rule, base changing rule is what? Logarithm of a to the base b is logarithm of a divided by logarithm of b. Okay, so here no problem, because here it is, the rule is, here the rule is, base is e, so there is no problem. You can simply differentiate here, okay, 2 times. If you differentiate, you will directly get your answer. So y is equal to logarithm of, you know dears, logarithm of a by b. What is that? Log a minus log b. I'm going to use that. So logarithm of x square minus logarithm of e square, right? Logarithm of x square minus logarithm of e square. I can simply differentiate this. Y dash is equal to, or it's the first order derivative dy by dx. What's the derivative of logarithm of x square? It is 1 by x square. Hope you all remember our chain rule, which is just explained. Okay, what is that? Logarithm of x, derivative is 1 by x, so it's 1 by x square. Now you have to multiply with derivative of x square, that is 2x, minus logarithm of e square. What is that? 0. Clear? So because logarithm of e square means there is no variable. There is no variable. So you don't need to consider that. Then you can cancel this x and this x, so that you will be getting y dash is equal to what? 2 by x. Am I right? Now it is very simple. Again use chain rule. D square y by dx square, or y double dash is equal to what? Equal to what? Derivative of 2 by x, right? So 2 into constant, take it. Okay, constant we take outside. 2 into, what is that? 2 into derivative of 1 by x. 2 into derivative of 1 by x. What is derivative of 1 by x? Formula is what? Negative 1 by x square. So we got the answer, beautiful answer we got, minus 2 by x square. That's there in your options, option D. Hope you got it. It's clear, I guess. Okay. Next question. What is that? E raised to x plus e raised to y equal to e raised to x plus y. Then what is dy by dx? Okay. So, students, first we will start applying logarithms. Like when we have a question with a raised to x, a raised to y, that kind of questions, we will have a tendency to apply logarithms. But here don't use logarithms. Why? Because logarithm of a plus b is not defined. Okay, logarithm of a into b only defined, right? So I can differentiate here, directly differentiate. E raised to x derivative is e raised to x plus e raised to y, chain rule, e raised to y into y dash. Students, for convenience, instead of dy by dx, I am writing y dash. It's okay, right? It's fine, right? Okay. Now next is e raised to x plus y into bracket. Okay, e raised to x plus y, because derivative of e raised to x is e raised to x itself. So e raised to x plus y means e raised to x plus y into derivative of x is 1 plus derivative of y is y dash. Clear? Hope it is clear to all of you. Now everybody knows it is an implicit function. Now you have to collect y dash terms. Y dash terms to be collected. So this is e raised to x plus e raised to x into e raised to y into y dash equals to e raised to x plus y plus e raised to x plus y into y dash. Clear? Take y dash term outside. Clear? Y dash term outside, so that I will get what? E raised to y minus this one comes to the LHS as negative. E raised to x plus y into y dash equals to other two terms e raised to x plus y. Keep it on RHS itself. This is to be brought to the RHS. What is happening to me, dears? E raised to x. Okay. E raised to x. Right. I got like this. E raised to y minus e raised to x plus y into y dash is equal to e raised to x plus y minus e raised to. Okay. I can substitute. I can find out dy by dx. What is my dy by dx? Dy by dx equal to. Okay. Dy by dx equal to what? E raised to x plus y minus e raised to x divided by e raised to y minus e raised to x plus y. Yes, this is my answer. This is what I'm getting, but I don't have that kind of any options, right? I don't have that kind of any options. This is the answer I'm getting. So what to do? This is the answer I'm getting, but that answer is not there in the options. Look at the question, dears. Look at the question. What is e raised to x plus e raised to y? Is e raised to x plus y. So wherever e raised to x plus y is there, replace e raised to x plus e raised to y. E raised to x plus y has to be replaced by what? E raised to x plus e raised to y. So you will get e raised to x plus e raised to y minus e raised to x divided by denominator same thing, e raised to y minus means very dangerous, you have to put a bracket, okay, minus e raised to x plus e raised to y. If you don't have a bracket, of course there is chance of making errors, okay, so please put bracket after negative if you have more than one term, okay. That is equal to, I can cancel these two. Okay, I'm getting e raised to y divided by denominator e raised to y cancel. So minus e raised to x. So very beautifully I'm getting that minus sign will go to the numerator. A raised to m by a raised to n. What is that? A raised to m minus n. Correct? So my answer is minus e raised to y minus x. Option C is coming as the answer. Hope it is clear to all of you. Next question is, the derivative of sine inverse of 2x into root of 1 minus x square with respect to sine inverse of x. You know, right? What is dy by dx meaning what? Dy by dx means what? Derivative of y with respect to x, correct, no? So here derivative of f of x with respect to g of x. What is that? It's another version of chain rule, right? D by dx of f of x. D by dx of f of x by d by dx of g of x. Derivative of a function with respect to another function is what? It's the another version of chain rule. Okay. So d by dx of f of x divided by d by dx of g of x. So sine inverse of 2x into root of 1 minus x square, of course, inverse trigonometric function. So that means you should have a substitution. Then that sine inverse will be getting cancelled after we substitute a proper substitution for x. Am I right? So sine inverse of 2x into root of 1 minus x square. We will be coming to the question. Your f of x is sine inverse of 2x into root of 1 minus x square. Okay. So you have to be very familiar with these all things, because the thing is that it is asked for what mark? 1 mark question it is. So if you are not familiar, means we will start doing at the examination time only, right? So it will take more time. That's why we need to have more practice. So maximum number of questions to be practiced, then only we will be very familiar with proper substitution and all. So sine inverse, those are very, very familiar with that function. 2x into root of 1 minus x square. What is the substitution that you have to make? Of course, what is that? X is equal to sine theta. X is equal to sine theta. So what you will get? When I substitute x is equal to sine theta, I will be getting 2 sine theta root of 1 minus sine square theta. What is that? Root of 1 minus sine square theta is root of cos square theta. That is cos theta, which is sine 2 theta, right? So what is that? Sine inverse of sine 2 theta. What is that? Sine inverse of sine 2 theta. That is equal to 2 theta, right? That is equal to 2 theta. But theta is what, dear? Sine 2 theta is your x, right? So theta is equal to 2 theta is equal to sine inverse of x. Oh, sorry. X is equal to sine theta. X is equal to not sine 2 theta. What happened to me? So, theta is equal to what? Sine inverse x. So, here 2 sine inverse x. That is your f of x. Your f of x is 2 sine inverse. Same question, dear. Same question. You can expect in inverse trigonometric function. Simplify this function. Simplify this function. So, you have to simplify this function means you have to write this function in this format. So, the same thing is asked here as derivative. That means these all things are interrelated. Okay. Now, I got f of x. Now, I will be checking what is happening to my g of x. Okay. We will see what is my g of x. Of course, it is very simple function sine inverse x. Okay, you know the derivative of. Okay. So, what is derivative of 2 sine inverse x? F dash of x. Is f dash of x? Derivative of f of x by derivative of g of x is derivative of f of x with respect to g of x. Correct. So, f dash of x means 2 by root of 1 minus x square. And here g dash of x is equal to what? Again 1 by root of 1 minus x square. Right. So, you can differentiate. So, you will get f dash of x by g dash of x. So, what is your answer? What is your answer? 2 by root of 1 minus x square divided by 1 by root of 1 minus x square. X square cancelled. Answer is 2. Okay, so this is how we find the derivative of a function. So, hope it is clear to all of you. Next question is, yeah, this is the question. The point or points at which the function f given by f of x equal to x by mod x. X by mod x when x is less than 0 and equals to negative 1 when x is greater than or equal to 0 is continuous. Okay, so at what all x values? Is there a, single value or multiple values are there? That's why it is written is bar o r. Okay. So, for which all x values this function is defined? This function is continuous. So, we know that what is continuous function? LHL equal to RHL equal to at the point, right? LHL equal to RHL at the point. We will see. So, LHL is what, dears? What is LHL? Limit x is tending to 0 minus f of x. See, I have the indicated point here is 0. But I am asked to find whether it is continuous at all points because option A is what? X is belonging to R every real value, or is it continuous at all? Only at x equal to 0, like that I have to check. Anyways, I am first now doing for x equal to 0. After that, we will see what is happening to other points. Okay. So, limit x is tending to 0 minus f of x. What is that, dears? What is that? Limit x is tending to 0 minus. 0 minus, you should remember about definition of modulus function. What is that? Modulus of x equal to positive x when x is greater than or equal to 0 equal to negative x when x is less than 0, right? Modulus of x is what? Positive x when x is greater than or equal to 0 equal to negative x when x is less than 0. So, 0 minus means what? It is very close to 0. Okay, I am admitting that, but it is Very close to 0, but it is in the left side of 0. Left side of 0 means what? It will be negative, right? It will be negative. That means x is less than 0. So what is modulus value? Modulus x function is equal to what? Minus x. So it is limit x is tending to 0. Limit x is tending to 0 minus f of x is x divided by negative x. What is that? X by negative x. What is the answer? X by negative x. Answer is minus 1. Clear? So LHL is minus 1, right? LHL is minus 1. RHL is already given in the question as what? Minus 1, because see, x is greater than or equal to 0. Greater than or equal to 0 means, if I do right, limit x is tending to 0 plus f of x. 0 plus, it's very close to 0. It's very close to 0, but it is greater than 0, 0.1 or 0.2, whatever. So it will be 0.01. It's very close to 0. Of course, so it will be what? What is the value of the function? It is minus 1. It is minus 1. Clear? So it is RHL is equal to minus 1. So LHL, RHL, and even at the point at x equal to 0 is also minus 1. F of 0 is also minus 1. Literally saying all the three are coinciding. Limit LHL, limit x is tending to 0 minus, limit x is tending to 0 plus, and f of 0. All three are coinciding. So answer is, it is continuous, of course, at x equal to 0. At x equal to 0, it is continuous. What will happen to other points? Let us check. Okay, what will happen to other points? We will see. Okay, I did only at x equal to 0. At x equal to 0. So I will be checking what will be happening to other points. As it is an MCQ question, I don't need to prove it. I will simply check what is happening to positive real values. What is happening to negative real values? I'll be simply checking. So positive real value, let it be 1. Okay, let it be 1. We will see. Limit x is tending to, you can take 5 or 6 or whatever. Limit x is tending to 1 minus f of x. Okay, 1 minus f of x. What is happening to this one, dears? 1 minus means what? 1 minus means what? It is tending to 1 but very close to 1, right? It will be like a 0.99, something like that, correct? So you can see this interval where this value is coming 0.99, where it is coming 0.99, where it is coming greater than or equal to 0, right? So LHL is minus 1, and I'll be checking what is happening to my RHL. 1 plus f of x, 1 plus f of x. What is happening to my RHL? Of course, same thing, right? Because RHL, there is no doubt, greater than 0. Like 1 plus. The problem is students will make with, error with LHL. Because 1 minus, whenever see minus we will take the first interval. Please don't take, because 1 minus means it's very close to 1, okay. But it is to the left of 1. It is to the left of 1, very close to 1. Left of 1, very close to 1 means still it is greater than 0. Still it is greater than 0, right? It is very close to 1. To the left side of 1. So it is greater than 0. So all the values are coming in this interval, right? 1 plus, 1 minus, even 1 also coming over there. So my LHL, RHL, even at the point is also same. Correct. So I just took one positive real value. Let me check with negative real value as well. Negative real value, if I take, okay dears, I'm rubbing this off, okay. Negative real value if I take. So what is, for the time being, what is our conclusion? It is continuous at x equal to 0 and it is continuous for every positive real value. That was our conclusion. Now we will see limit x is tending to, I'll take x is equal to negative 2. Negative 2. Just I'm taking a negative real value. So what is happening? Minus 2 minus f of x. Okay. Minus 2 minus f of x. So minus 2 means it's close to minus 2 but left side of minus 2. Like your x value will be minus 2.01 something. right? It's less than minus 2 but very close to minus 2. Okay, so my answer will be, what is that? Minus 2.01. It's coming where, dears? It's coming over here. It's coming over here, right? X by mod x. So answer is x divided by modulus of x is equal to x by negative x, because when x is less than 0, mod x equal to what? Negative x, right? So x by negative x, that is negative 1. Correct? E1 minus 2 plus also same thing, right? Limit x is tending to minus 2 plus. Minus 2 plus means what is the value of the function? Minus 2 plus also the same thing, right? Because x is equal to, it is coming like minus 1.99, but still it is less than 0. So it's coming under the first bracket itself. Okay, still it is less than 0. So here itself it is coming. So again x by negative x, because even if it is minus 2 plus, the value is negative, minus 1.99. So that modulus of x is negative x only, right? So the answer is again negative 1. Clear? So it is for x equal to minus 2, the same value. So that means every real value, this is continuous. That means it's an everywhere continuous function. It's an everywhere continuous function. Okay. So you can write your option. So this one, the same question, if they ask you as a, 3-mark question and all, you have to take as 3 cases and to prove, you have to prove it. First x equal to 0, then a greater than 0, case 1, a less than 0, case 3. X a equal to 0, a is greater than 0, a is less than 0. Hope it is clear. Okay. So again I am saying you have to be very familiar with all these type of functions. Then you can write the answer in a faster way for MCQ based question. Okay. Next is f of x equal to 1 divided by 1 plus e raised to mod x, where x is not equal to 0 and equal to 0 when x equal to 0, then f of x is. Again, see where. So these all questions were from previous board paper questions. Okay, all are from previous board paper questions. So previous board paper questions, you can see everywhere what is coming, modulus function. So it is very important function. Okay, so we will see. I'm just rewriting this function like this. F of x equal to, because you know mod x is, mod x we can split as what? Positive x when x is greater than 0, negative x when x is less than 0, and equal to 0 when x equal to 0. So I can write here as 1 divided by 1 plus what? E raised to mod x is e raised to positive x when x is greater than or equal to 0. Or equal to 0, greater than, because equal to 0, it is equal to 0 already given to you. And 1 by 1 plus e raised to negative x when x is less than 0, right? Clear? And equal to 0 when x equal to 0, equal to 0 when x equal to 0. So this is the function given to you, that is modified. Okay, we modified that function to this format. Now I got like this, and I need to know whether it is differentiable and continuous. Both they asked whether function is differentiable but not continuous at x equal to 0, whether the function is continuous or differentiable and continuous but not differentiable, etc, etc. So we start with continuity. Okay, so continuity, when I start, I'll get, let me check what is that. LHL, limit x is tending to 0 minus f of x at x equal to 0, it is asked, right? Everywhere options all are at x equal to 0. So limit x is tending to 0 minus. 0 minus means what is the value of the function, dears? 1 by 1 plus e raised to minus x, and the x value is tending to 0. So that 1 by 1 plus e raised to negative 0. E raised to negative 0 means e raised to 0 only. E raised to 0 is equal to 1, right? So it is 1 divided by 2. Clear? RHL equal to limit x is tending to 0 plus f of x equal to 0 plus f of x is what? Of course, the same thing comes 1 divided by 1 plus e raised to 0, that is again 1 by 1 plus 1, that is 1 by 2. But your at the point is what? Oh, sorry. At the point value of the function is what? That is what? Answer is what? At the point answer is 0. F of 0 is not coinciding with the LHL RHL value. Means what is our conclusion? It is not continuous. It is not continuous means of course it is not differentiable as well. It is not differentiable, right? Function is not differentiable also. So that kind of one option is not here. So you can write none of these. First option is differentiable but not continuous at x equal to, that will never be happen, right? You know, right? If a function is differentiable, of course it will be continuous. Second option is continuous as well as differentiable. No, it is not continuous. Continuous but not differentiable. This is not continuous. Okay, this is not continuous. So I don't need to check the differentiability. So the answer is none of these. Okay.